Welcome to section 9.1. Let's talk about circles and parabolas. As a matter of fact, I'm going to assume that you have a pretty good reference of working with circles. There's a good chance that you've been doing that for a number of years. I do want to point out our standard form for the equation of a circle. HK would represent the center. R, of course, is the radius. But if I was to take the square root of both sides here, I would get R equals, and we could argue plus or minus R when we take the square root, but the radius is going to be positive, would equal the square root of x minus h squared plus quantity y minus k squared. And that should have a familiar feel to it. That is just the distance formula. And the distance formula, Pythagorean Theorem, equation of circle are all, you could argue the same, but at the very minimum, very, very tightly related. And you'll see some of that as we move on. And then as we get into parabolas of our conic sections, and you may want to refer back to this because I'm not going to go into a lot of detail in here. An important thing to remember when we're getting into our when we're getting into our standard equation of a parabola, HK is the vertex. This p-value that's referred to, that is the distance from the vertex to the directrix and from the vertex to the focus. P is a length, but P could be negative. And when P is negative, we'll be talking about that. It just means that when P is less than 0, it means that the parabola is opening in a negative direction. For instance, down here, when P is less than 0, to the left there. We're very comfortable working with x squared parabolas that open up and down. So when we see a y squared parabola, x to the first, y to the second here, we shouldn't be surprised that those open right and left. But that p-value, very important in real-world situations. I tell classes this: you've worked with parabolas, but you've never really worked with parabolas, because if you're not dealing with the focus, the whole real-world application of parabolas is pretty much out the window. So anyway, you're going to want to refer back to some of this, but I'm going to go ahead and get started with some examples. This first page, we've got a lot of circle examples, which we should be pretty comfortable with. And I'm going to go through these fairly quickly. Find the standard form of the equation of the circle. So x minus h squared plus y minus k squared equals 1, where hk is the center. Well, we've got the center. So x minus the x coordinate, 6 squared, plus y minus negative plus 3 squared equals r squared. And then we've got a point that's on the circle. And if I was to sketch this, I'm not going to sketch the whole circle. But we've got 1, 2, 3, 4, 5, 6, negative 3. And we've got a point on the circle at negative 2, 1, 2, 3, 4. We might be tempted just to go ahead and build this triangle. There's the radius of our circle from this point to here. And we could just Pythagorean Theorem that. I'll come back to that. Alternatively, we could take this solution point and plug it in for x and y. And once x and y have numerical values, we can solve for r. So negative 2 minus 6 squared plus 4 plus 3 squared is r squared, or negative 8 squared, 64, plus 7 squared, 49, is r squared. R squared is 113. Now, let's go back. I said I was going to talk about how this is related to Pythagorean Theorem. If we go back to here, I'd see, well, this was to the right 6, this is to the left 2, so this is 8. And this distance is from down 3 to up 4, is up 3, up 4. That's 7. It's just Pythagorean Theorem. And if I take the square root of this thing, it's just distance formula. They are all the same. So we end up with our standard form, x minus 6 squared plus quantity y plus 3 squared equals 113. Not 113 squared. The squared's already built in. If you want to have a squared in there, then it's square root of 113 squared. Okay, now we've got endpoints, and I know this: if I've got endpoints of a circle, the midpoint of those would be the center of the circle. And surprisingly, in class, I asked the other day, how many of you have found yourself at times forgetting the process or the formula for finding the midpoint of a pair of points? And I would say more than half of the hands went up in an honors pre-calculus course. And that's a little disturbing because this isn't a formula that you should memorize in the first place. How do you find halfway between two numbers? That's the average of two numbers. If I call this M, our midpoint here is the average of the x's, 1 plus 9 over 2, comma, the average of the y's. So our midpoint is 10 on 2, 5, negative 12 on 2, negative 6. So we have an equation of the circle that's centered here, x minus 5 squared plus quantity y minus negative 6, y plus 6 squared equals r squared. And once again, we can plug in either of these. Neither of them are particularly favorable. I think I'll go with the first point. 1 in for x, negative 7 in for y, and I get negative 4 squared 16 plus negative 1 squared 1 is r squared. So we end up with quantity x minus 5 squared plus quantity y plus 6 squared equals 16 and 1, 17, not 17 squared. Okay, 19 and 26. Write the equation of a circle in standard form. Then identify the center and radius. Well, my center is 0, 0. My radius is to be determined. For standard form, I'm going to multiply both sides of this by 2/9, and I get x squared plus y squared equals 2/9. So our center is 0, 0. We knew that. And our radius is the square root of 2 over the square root of 9, or over 3. And that is it. Not supposed to graph yet. Now this problem we're going to need to complete the square, which we were working on in the previous section, or previous sections in the book. But anyway, I want to group my x's and factor out a 9. So I get 9 times x squared plus 6x, leave a blank. Now important to note here, if this was 17x squared and 54, I would still factor out 17. I'd get 17 times x squared plus 54 on 17, x. It would be a mess, but what I'm saying is I don't care what's behind my pen here. I have to factor that 9 out. You could also originally divide everything by 9, but I don't want to work with that fraction. You'll see the payoff for that. And then plus, group the y's, factor out a 9 because we have to. Y squared, oh, that's good news, minus 4y. Leave a blank, subtract 17. So at this stage right now, I have the same equation as I had up here. It's just been rearranged. To complete the square, when we have a lead coefficient of 1 here, we can take half of the b term, 6 on 2, and square it. That gives me 3 squared 9, put the plus 9 here. But that value right there was not there. Okay, I'll come back to that. Half of negative 4 is negative 2 squared is positive 4. I put in plus 4 here. That value was not there, so I have to balance for that. But I didn't really add 9 to this side. I really added 81. And I didn't really add 4 to this side. I really added 36. So you need to be careful with that. So I've got 9 times x plus 3 squared plus 9 times y minus 2 squared, when I factor that, equals, this is conveniently 100. Divide 9 on both sides. X plus 3 squared plus y minus 2 squared equals 100 on 9. So our center is negative 3, the myvox I refer to, most interesting value of x, positive 2, the myvoy, most interesting value of y, 2, And our radius is the square root of 100 on 9, or 10/3. All right, let's move on. Sketch a circle, identify its center and radius. Same initial process here. I'm going to go ahead and complete the square. Group my x's, x squared plus 6x, leave a blank. Group my y's, y squared minus 12y, leave a blank. Equals, subtract 41 on both sides. Half of 6, 3 squared plus 9. And you don't really need to work with the negative here, because half of negative 12 is negative 6 squared, but that's the same as 6 squared. So I might just say half of 12 squared 6 squared plus 36. This time I truly did just add 9 and add 36. There was nothing to distribute through those. We get quantity x plus 3 squared plus quantity y minus 6 squared equals 45 minus 41, 4. So we have a center of negative 3, 6, my box, my boy, and a radius of 2. So I'm going to set this up. I need room to the left and I need room up. And you'd say, well, I need to go over to negative 3, but then I'm going to have a radius of 2, so I'm going to go 2 beyond that. Need to go up to 6, 1, 2, 3, 4, 5, 6, but I have a radius of 2, I'm going to go 2 above that. Negative 3, 6, center, 2 to the right, 2 up, 2 to the left, 2 down, and we're going to try to do the best we can to give ourselves a decent circle here. It wasn't very good there. Sometimes I do well. Okay. So anyway, sorry if you didn't see the scaling on the bottom there. So that is it. Let's go ahead and take a look at 38. Find the x and y intercepts of the graph of the circle. Well, x-intercepts. X-intercepts, these points that are on the x-axis, all have one thing in common, and that is they are something 0, something 0. So x-intercepts occur when y equals 0. So x plus 7 squared plus 0 minus 8 squared equals 4. You might be tempted to FOIL this. You're going to see there's a payoff not to. Negative 8 squared is 64, so plus 64. X plus 7 squared equals negative 60. X plus 7 squared equals plus or minus square root of negative 60, which would be an indication we don't have any x-intercepts. I do want to point this out. Let's say that this had been positive 60 in there. Then my solution would just be x equals subtract 7, have it join a plus or minus square root of 60, and maybe break the 60 down. And you can see that kind of has that whole quadratic formula feel to it. Since I didn't FOIL this out, I wouldn't have had to go to quadratic formula. So anyway, there are none. Let's see if that makes sense. This is a circle. Center is left 1, 2, 3, 4, 5, 6, 7. And up 1, 2, 3, 4, 5, 6, 7, 8. And it only has a radius of 2. Just a little bit over, a little bit over, a little bit up. So not only does it not have x's, if we were trying to find the y-intercepts when x equals 0, ... we would come up with none for that. Okay, number 40. Let's see if we get some intercepts here. For x-intercepts, y equals 0. I don't have to put this into that form. I can just put in y equals 0. And that gets me x squared plus 8x plus 0 plus 0 plus 9 equals 0. Try as you might, there are no factors of 9 that add up to 8. Tempting to say 9 and 1, but positive 9, positive 1 would work for 9 but not for 8. And negative 1, negative 9 work for 9 but not for 8. So quadratic formula. Opposite of 8 plus or minus square root of 64. Minus 4 times 1 times 9 minus 36, all on 2 times 1. Negative 8 plus or minus square root of 28, all on 2. 28 is 4 times 7, so negative 8 plus or minus 2 square root of 7 on 2 for final answer of the x-intercepts are negative 4 plus or minus square root of 7. Okay, let's find the y-intercepts. That's when x equals 0. I get 0, 0. Y squared plus 2y plus 9 equals 0. No factors of 9 that add up to be 2. So opposite of b, plus or minus square root of b squared, 4, minus 4 times 1 times 9, minus 36, dot, dot, dot. We have none because our discriminant is negative, of course. All right, we got bells going off at the school like crazy right now. All right, matching. This is a nice section, except there's a couple problems in it, I think, at this stage right now. It'll make for good conversation. But if you take a look at these parabolas, this is a y-squared parabola, and I would refer to it as positive because it opens in a positive direction. So this is a positive y-squared. This is an x-squared parabola, positive x-squared. This is negative x-squared, and it has a moved vertex. This is negative x-squared. And its vertex is at the origin. This is a negative y squared vertex at the origin and a negative y squared vertex at the origin. I think the author might not have wanted to put both those in at this time, but it will lead to a good discussion. So I'm going to jump down. In fact, I'm going to look at this problem first and look for a matching with it. This has what appears to be a vertex close to 3, 1. It looks like around 3, 1. And as I look down here, well, here's a 3 and here's a 1. But when x is 3, this is 6. When x is 3, this is 0. When y is 1, this is 0. And this is a positive y squared. This is it. This is A. Plus, it couldn't be 48 because this is an x squared and we're looking for a y squared. So quickly, our eyes might shoot to this one over here, where our most interesting value of x is appears to be negative 3, and y appears to be, the y-coordinate of the vertex appears to be 1. It is an x squared, and it is upside down. So no question, this is C. These two are going to cause problems, but here is a positive x squared. It's this one, positive x squared. This would be the negative x squared. So this is B, this is D. And now for these last two, a little bit sneaky, but I'm going to look at this point right here that appears like it might be about negative 3 and about 6. And if I take negative 3, 6 and plug it in here, I'm going to get 36 is supposed to be equal to 12, and that's not even close. So I'm going to try negative 3, 6 in here, and I get 36. Negative 12 times negative 3 equals 36. Ooh, that's this one. That is F. And the interesting part about this is what we can take away from that. It appears that the bigger value of P, this is in the form y squared equals 4P times X. So P has a larger value, although it's negative, than this P value. This is 1, this is 3. The bigger value for P apparently seems reasonable to assume that from this point on that will widen out the parabola. But we'll have more talk about that. Excuse me. Okay, find the standard form of the equation of the parabola. So this is a y squared parabola. It would be in this form, y minus k squared equals 4p times x minus h. What we know is it's backwards, so p is less than 0, and we know that the vertex is at 0, 0, so this is really y squared equals 4px. So we just need to know what p is. Well, what else do we know about this other than it's a y squared and it's backwards? It's opening in a negative direction. Well, we have a solution point. And what else could we possibly do with that solution point than use it to put 6 in for y and negative 2 in for x? And now I can solve for p. So I get 36 equals negative 8p. P is 36 divided by negative 8, or negative 9/2. Substitute that back in for p, and I get y squared equals 4 times negative 9/2 times x, which is kind of a useful form, but probably the back of the book distributes that, and we get negative 18x. All right, let's take a look. 52. Vertex is at the origin. Let's not forget in this section. And I'm going to draw a sketch of this thing. Vertex is at the origin, and we have a focus 0, 3. I see a lot of people mess this up, and I think it's just because, you know, we're so focused in on the parabola stuff, we forget the easy stuff. 0, 3 is up 3, not to the right 3. So there's our focus. Here's our vertex, which means this thing opens something like that. So what do I know about this? This is an x squared parabola, and p is greater than 0. Since the center is 0, 0, it's just x squared equals 4py. And the value of p, as we mentioned earlier on that first sheet, the value of p is the distance from the vertex to focus, or the vertex to the directrix. And we've got the vertex to the focus is 3. Just got to make sure we use the length of p is 3. In this case, the value of p is also 3 because it's a positive parabola. So I just get x squared equals 4 times 3 times y, or of course x squared equals 12y. And directrix 5, x equals 5. 1, 2, 3, 4, 5. There's our directrix right here. There's our vertex. The parabola opens away from the directrix and around the focus. So the focus is, if we needed it, is over here. We got a parabola that looks something like this. So that is a negative y squared. P is less than 0. And we've got a y squared equals 4px. What's the length of p? The length of p is either 5 or 5. What's the value of p, though? Negative 5. And we get that because we know it's opening in a negative direction. Okay, one more page, 4 more examples here. They don't get much tougher, although this graphing, we're going to really focus on controlling the width of the parabola, and that's going to come back to our geometric definition. And our definition of a parabola is the set of all points in a plane that are equidistant from a fixed line called the directrix and a fixed point called the focus that's not in that line. If you notice, this point right here is the same distance as this is to the directrix. This point out here would be the same distance to the directrix if I called that D3. So we need to know that, but we're going to actually apply it in this problem. So this is in standard form. This is in the form y squared equals 4px. So 4p is equal to 3. P is equal to 3/4. This is a positive y squared parabola. The vertex of this parabola is at 0, 0. Most interesting value of y and x. So at 0, 0, I've got my vertex. This thing is positive, and it's y squared, so it's opening. I'm just giving myself a little information here. I'm going to come back and draw that better in a bit. But it's opening this way, and the focus is out this way at 3/4. The directrix, so the focus is, before I talk about the directrix, is at 3/4, 0. The directrix is left 3/4, but it's a line. And that, of course, is the line x equals negative 3/4. And so here it is. Nothing new there, except what we're about to do now is we're about to talk about controlling the width of this. And see, the vertex is on the parabola because it's equidistant from the focus and the directrix. And both of those are 3/4. We've got 3/4 here and 3/4 there, and 3/4 and 3/4 gives me a total distance from the focus. I'll show you where I'm going with this. From the focus to the directrix of 1.5. 6/4, 3/2, 1.5. If I go to the focus, steal some room here. I want to try to draw this sort of to scale, or sort of square. If I go from the focus and I go up 1.5, that point right there is 1.5 away from F, of course, but it's also 1.5 away from the directrix. And if I go down 1.5, that point's 1.5 from the focus, 1.5 from the directrix. And that gives me an idea of how to control my width of the parabola. Rather than just say, well, it looks like this. We're going to get it close. We're going to hit those 2 points at the end of the lattice rectum here is what it's referred to. You'll see that again in 74. Hopefully that'll make sense to you. That's an issue on the test for some people. So here we need to get this in standard form. X squared minus 2x. I'm going to leave a blank. I'm going to add, excuse me here. I'm going to start that one over. I just had a little distraction. I'm going to go x squared minus 2x. I'm going to leave a blank. I'm going to go equal, subtract 8y, subtract 9. I take half of negative 2, 1, square it, plus 1, balance my equation, plus 1, and I get x minus 1 squared equals negative 8y minus 8, or x minus 1 squared equals negative 8 times y plus 1. So our vertex is at 1, negative 1, and P, 4P is equal to negative 8, P is equal to negative 2. Let's take a look what this looks like. Vertex at 1, negative 1, and I need to divide by, well, I've divided by 4. I've got a p-value of 2, but this is a negative x squared graph. Negative x squared. So it's opening down. And the focus gets wrapped around, so we're down 2 from here. And the focus is at 1, negative 3. The directrix then is the other direction. The directrix is y equals 1. And now I'm going to control the height. And to control the height, I'm going to say the focus to the directrix is a length of 4. If I go out 4, this point right here is 4 from the directrix, 4 from the focus. Therefore, by the definition of a parabola, it's on the parabola. Likewise, to the left, 1, 2, 3, 4. 1, 2, 3, 4. That point is on the parabola. And that leaves me with 3 short problems, but unfortunately I am out of time here, so I will need to do a part 2 for that. But stay tuned. Let me know if I can help.